This question, we have a momentum time graph. The first time we're seeing a momentum time graph in one of these questions. We'll do our Oy-Zerga analysis. Our origin is 0, 0. Y-axis, momentum. In normal units, kilogram meters per second. X-axis is time, so therefore any questions about momentum or time will be red. The gradient is delta P over delta T. The rate of change of momentum is the definition of the average force. And the area is P delta T. And if we look at the units, kilogram meters per second times seconds, we cancel out the seconds and we're left with kilogram meters, which has no value to us. Now, we said the slope of this is the average force, and if we draw the best fit line, maybe something like that, that slope would give us the force if we wanted it. All right, so now what we can see then is that this, the slope is constant. So the force is constant. The rate of change of momentum is constant. The momentum is increasing. P equals mv. All right, so cart travels to the right on a track. Moving like that to the right. Friction is negligible. Good, so no friction. Momentum of the car is modeled in the graph. Which are true for the time recorded? Select two answers. Which is true? The change in momentum of the car is nearly 1.9 kilogram meters per second. Well, the question is asked, that is about momentum. So that, so we're just going to read that off the graph. That's just, we're going to read it off. And so, if we look at the total momentum at the end, it's not even 1, and it started at almost 0. So it can't possibly be 1.9 if at no point is the momentum even 1. The impulse delivered to the car is nearly equal to 0.75 kilogram meters per second. Well, all right, so the impulse J is equal to the average force times the time, and the average force is the slope. So 5 seconds is the time, and the slope is about 0.85 over 5. You say 0.9 over 5, and that's going to be about 0.14. 0.14. Oh, and the time is 5 seconds. So we're left with 0.14 times 5, 0.9. So J is 0.9, not 0.75. We calculated the slope and found it to be 0.15. So that looks like the true answer. The work done on the car is nearly 1.5 joules. Well, I wouldn't have selected this question if we could answer the question about the work done. So we're looking for that second choice, and it turns out I misspoke earlier about that 0.75. The impulse is equal to the average force times the change in time. And the force, we said, was constant. But it's also equal to delta P, which is equal to m delta V. The impulse is equal to the change in momentum. Now, the change in momentum, we ended up with, ended with 0.88, let's say. And it started with about 0.10. So we're looking at about 0.75 if we look at that change. The change is really about 0.75-ish, not the full value read off. So the change in the impulse, change of momentum in the impulse are the same, and that's why those two are our correct answers.